Back-to-back atmospheric rivers slammed the west coast this winter, triggering deadly historic flooding. Scientists say these storms are getting stronger, but there's a lot that we don't know.
Meteorologist Leah Pizzetti with our Environment Northwest team took flight with hurricane hunters to better understand the work being done.
December of 2025.
There are going to be some serious impacts to communities.
Torrential rain and catastrophic flooding hit every western state.
The flooding levels we're looking at are potentially historic in nature.
From the Northwest,
all of western Washington should be on alert.
To the Golden State.
The storm system that soaked our state this week is blamed for at least 3 deaths.
Across the West Coast, 5 reported deaths, all blamed on multiple atmospheric rivers in 1 month alone. That's why scientists are bringing in the people who don't fly around storms, but into them.
Hurricane season starts June 1st, goes to the end of November, and we're on call for anything and everything during that time.
The hurricane hunters gather crucial information that shapes accurate forecasts, but despite the name, that's not their only job.
You are clear for drops unless otherwise stated.
This is one of the aircrafts used by the hurricane hunters in the summer and the fall. Their fleet flies into and around hurricanes to measure those storms, but it's not taking a break in the winter. This aircraft spends the winter on the West Coast, flying into atmospheric rivers to better understand these strengthening, powerful storms.
So we'll translate the atmospheric river one time, come back around.
For the last 10 years, the hurricane hunters have spent the first 3 months of the year based in Portland.
Really deep trough here, more narrow jet streams.
Doing exactly what they do for hurricanes.
Today's atmospheric river mission involves 24 drop zones.
But over the Pacific Ocean, measuring atmospheric rivers.
They are literally river in the sky. The only difference for rivers that rather than transporting water, the transport is about water vapor.
A massive plume of moisture, thousands of miles long, that can transport 10 trillion gallons of water per day. Too many can cause flooding, not enough can cause drought.
But for the West, what really matters are atmospheric rivers. And so that is kind of been overlooked by the last few years. That is the reason our center came about and has been growing very rapidly, because it's a very important phenomenon for the Western United States.
Luca Delle Monache is the Director of Research at the Center for Western Weather and Weather Extremes, part of Scripps Institution of Oceanography out of UC San Diego. He says research into these storms didn't really start until the early 2000s, with his colleagues leading the way.
Some of the historical reason is that the weather community has been focused on other impactful events, as hurricanes, of course, tornadoes.
So his team dove headfirst into that research, working to understand the storms and increase public awareness about severity.
And I think I can claim that our center put atmospheric rivers on the weather map.
Their studies show the damage costs are projected to triple from $1 billion a year to $3 billion by the end of this century.
It's financial for all of us, you know.
Costs felt in Washington's December floods.
A lot of work. I guess if you have to sum it up, a lot of work to be done.
To help with public awareness, the center launched a scale in 2019, ranking atmospheric rivers from 1 to 5, based on maximum intensity and length of time, similar to hurricanes.
Negative 1.2. 0.2, all right.
The hurricane hunters have also become atmospheric river hunters. Each flight, a team of meteorologists watch the weather.
Yeah, I would say we're kind of on the front lines of emergency response, how people respond to storms when they make landfall.
And in the back of this jet,
a drop operator, as we call it.
A team of 2 preps something called a drop sonde to release into the sky.
First, I calibrate them.
As it falls, this narrow tube measures data like temperature, humidity, wind, and pressure.
You'll see it's just a circuit board, and it's got a couple chips, and that's it.
The data collected fills an information void. The Pacific Ocean is basically a data desert.
We do have measurements from the satellites everywhere over the oceans, but those measurements provide, for the most part, information for the top half of the atmosphere, whereas atmospheric river and atmospheric river dynamics happens at the bottom part of the atmosphere.
And because a forecast is only as good as the technology available, every drop here gives them new information they'll later analyze on the power of each impactful storm.
Atmospheric river will determine if we're going to have a drought year or a wet year. And that will be even more so in the next few decades.
Because as the ocean warms, the air can hold more moisture, fueling these storms and the flooding associated.
You know, if we have to do this every 5 years, when do you put a check mark to say this is enough is enough?
This research has now become a global effort. Starting this year, they're doing this in every ocean basin with a goal of improving the extended forecast.
The idea being that by filling the gaps, the data void over the ocean, we can improve prediction much farther than what we can do right now, possibly for the week 2 of the forecast.
All of this is important because to understand the future, we need to have solid records of the past.
Forecasts can always get better. Our understanding needs to get better too. So every time we go fly, yes, we improve the forecast for that day, but the more often we fly, the more frequently we fly, the more years we fly and develop that large data set, that allows researchers like those at Scripps to actually start analyzing the data and start parsing out what's most important, what's least important.
Laying a foundation to prepare for when extreme weather hits the West Coast. I'm meteorologist Leah Pizzetti.